So this is the part 2 to our review video. We should have rhombi next in our flipbook. And so for our rhombi, we have those same parallelogram properties. But the ones that are new to rhombi is that all sides are congruent. So if you got one side, you pretty much have them all. People tend to forget that, and it's like the easiest property of rhombi. Again, it is for rhombi, not for squares, but we'll learn about those later. Then we do have diagonals are perpendicular. So you guys see this right angle here? If I were you, I would go ahead and just draw my 4 angles. That way I do not forget about them. So this is the 4 90-degree angles at the center. It's right here. And then that diagonals bisect opposite angles. So we have our angles here, 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 and there. They should all be the exact same measure. So this is 11, this is 11, this is 10, this is 10, this is 21, this is 21, so on and so forth. They should always be the exact same measure. And people forget about that as well. And they shouldn't, because it's actually really handy for us to solve for these. So let's look at our rhombus. So it does say that it is a rhombus right here. So again, in your test, just make sure and see what they are asking you or what they're telling you it is. That way you can use the correct properties for those. I'm going to work with my sides first. And they do ask me for XY. And so XY, I am going to look for an outside. This is 27, so I know this is 27, this is 27, and this is 27. So we already have one without having to do any math whatsoever. Then they ask us for WP. So at this point, we should kind of take a second to draw in our right angles. And so here we have WP, and it only looks like we have one side, but if we recall, this is 21, then this should also be 21. And then lastly, we have PZ. So PZ, it is part of our right triangle. Remember, we can always, and we're probably going to use Pythagorean theorem for rhombi and square at some point. So this would be the point there. So again, we have our C that is across our 90-degree angle, and so A and B can be pretty much whichever one you want it to be. So I will say that it's A squared plus B squared equals C squared. If we replace the things that we know our A is 21, so that'd be 21 squared plus B squared, we don't know that yet, equal to C squared, which is 27 squared. And so from then on, we would be solving for B, so I am going to subtract 21 squared from both sides. That way, I can have B by itself. So we are left with 27 squared minus 21 squared, and that does end up being 288. And so from here on, I can take the square root of both sides. Don't forget to take the square root of both sides, you guys. That is one of the most common mistakes. And then we do have B is equal to 16.9. So here, for PZ, that'll be 16.9. You probably are going to need the Pythagorean theorem at some point with these. So if you run out of ways to find a side, probably Pythagorean theorem will be your next bet. So I'm going to erase all of this because I am working on my angles next. And so I will be keeping my 90-degree angles here, so I don't forget about them. Let's look. It does say XZW, XCW, that's only half of this right here. However, we do know that they are being bisected. So this is 51, this is also 51 degrees. And we have XWZ, that is this entire angle right there. And so we have two angles here. I know this is 90 degrees. I know this is 51. And I also know that this is a triangle. So if I have two of the three that I'm missing, I can always do my sum of interior angles. And so all three of those do have to add up to 180. So all I would do there is subtract each of these angles from 180. So I would say 180 minus 90 minus 51, and that should give us 39 degrees. So XWZ, that gives us 39, so then this should also be 39 degrees. And so when you add those two up, then this would actually give you 78 degrees. So this entire thing is 78 degrees. And then last we have Z, Y, W. Excuse me. We have Z, Y, W. That is this angle right here. And we do have its alternate interior, which is 39. Therefore, this is also 39 degrees. Alright, so I want you guys to do number 6. And remember the hint there is that that angle is being bisected by that diagonal. So they should be the exact same measure. So get that checked, get your name tallied off, and then we will be moving on to squares. So remember, the squares are the ones that are really needy. So they have every single property that we have learned so far. They're all applicable to squares, so you can pretty much go ahead and use pretty much anything you want in order to solve these. So let's take a look. It says BCD is a square. So we can use all those properties in order to solve it, find each missing measure. So they first ask us about CE. But before we start, I'm going to go ahead and draw all 8 of my right angles. All 8 of these are important, and you might need to use them at one point. So we are first asked about CE. That's this diagonal right here. And so because I can use all my properties, I know that these two are congruent. Therefore, FE is also 8. And so 8 and 8, CE will be 16. Then we have BC. So BC is a outside side, but it doesn't have any numbers here. However, I do know this is 8, and because they're congruent, I know this is actually going to be 8 as well. So remember, this is a right triangle because we have this right angle here. So we can, again, split it up into 4 mini right triangles. And therefore, in this case, we'd actually be looking for our hypotenuse. Remember, these can be split into 2 big right triangles or 4 mini ones. So let's do the mini one. So we'd have a squared plus b squared equal to c squared. And then we do have a and b. They will both be 8. So this is actually going to be 8 squared plus 8 squared equal to c squared. This entire thing can be put into the calculator at once. So this be 128 is equal to c squared. And then last we take the square root of both of those, and we will have c is equal to 11.3. So this side right here is 11.3. Because we know this side, then we actually know all of them. So they don't ask us this in this case, but if it does on the test, then you'd know how to find that. So I'm going to erase all of this so I can work with a clean slate on my angles. So I will be drawing again my 8 right angles. And the first one they ask us for is CFD. CFD, we've already drawn that in. That's this angle right here, and we know that it's 90 degrees. And then we have DBE. DBE, usually on these, we don't know exactly how they're split, but because these are split in half and they're equal to 90 degrees, then these halves are always going to be 45 degrees. So there you have it. Do number 8. Remember, you have to put those 8 angles. And so once you put those 8 right angles, you can do either mini Pythagorean theorems or 2 big Pythagorean theorems. So that's a hint for number 8. Do go ahead and get it checked. And after that, we should be done with our test review. So keep these, and I will be checking them off Wednesday. If you don't finish this video in class, you do have to finish it at home. That way your homework grade can still be an easy 100 when I check it back the next day. Alright, I'll see you guys for your test.